Hello everyone, today we're focusing on Cambridge IGCSE Mathematics topic of number, subtopic of exponents and surds. So to begin with, we are looking at powers. Basically, when numbers are multiplied by each other a lot of times, it's difficult to write 2 times 2 times 2 times 2, for example. So instead of that, what you can simply do is you can write 2 to the power of 4, which means the same thing. It just means that 2 is being multiplied 4 times. Or when you have to write an expression like this, you can see that the 2 is multiplied twice, so you write that as 2 squared. 3 is multiplied twice, so you write it as 3 squared, and then there's the 5 at the end. Or you have 1/3 being multiplied 4 times, which you can then write as 1/3 to the power of 4. There are 4 rules regarding operations with powers. When multiplying the indices, now the important thing to realize is whether the bases are equal. Okay, so these rules cannot be used unless the bases are equal. So for example, if you have 2 to the power of 5 times 2 to the power of 3, since both of them are base 2, then what this can be simplified to is basically you can add the powers and this will add up to 2 to the power of 8. Same way, 2 to the power of 5 divided by 2 to the power of 3 means that you can subtract the powers and simplify it to 2 squared, which is then the answer when you're dividing. So when you're multiplying, you have to add the powers, and when you're dividing, you have to subtract the powers. So if we move on, the next rule is power of a power. So for example, if you want to work out 2 to the power of 3 squared, that's simply multiplying the two powers. So 3 times 2, so 2 to the power of 6 is basically the power of a power. If you want to find negative powers, now let's say I have 10 to the power of a negative number, like 10 to the power of negative 3. If I want to make this a positive fraction, what I have to do is basically take the 3 down to the denominator. So I can make this as 1 over 10 to the power of positive 3. Similarly, if I have 10 to the power of 4, when I take a positive number down to the denominator, it will become a negative number as well. Moving on, you can use this particular symbol in your calculator to work out any powers. Like for example, 4 to the power of 5 is 1025. You can follow these steps to help you understand that. Moving on, roots. Roots are basically the inverses of powers. So they are usually denoted by the symbol like this. And for example, if you want to find 3 root, 4 root, 5 root, you would have to denote as follows. So square root of 4 can be written as 4 to the power of half. Basically, any number, if you have the square root of it, you can convert that as a power of half. So I can simplify 4 to the power of half further. How can I do that? Because 4 is 2 times 2, so I can write that as 2 squared, and then using the multiplication of powers rule, I can multiply the 2 by half to form 2 to the power of 1, which is simply 2. So I can therefore say that square root of 4 is 2. Similarly, cube root of 27 can be written as 27 to the power of 1/3. Right, so if it's a square root, it is half. If it is a cube root, it is power of 1/3. And same way, I can simplify this, so I can convert my 27 as 3 cubed, and then using the power multiplication, I can bring this down to 3 to the power of 1, which is simply 3. So again, I can use the calculator square root option to calculate any types of root powers using my calculator. Coming to the final part, which is basically surds. Now surds is basically any number that when you square root, you don't get the exact value or an exact integer. All you get is decimal answers. So for example, if I want to work out square root of a into square root of b, this is the same as saying square root of ab, and that is rule number 1. So in an example, if I have square root of 2 and square root of 5, when I multiply those together, this is going to give me square root of 6. The same way, if I want to do a simplification, that is, if I have square root of 80, I know that 80 is the same as 16 times 5, which means I can break this square root into square root of 16 times square root of 5, and we know that 4 times 4 is 16, so square root of 16 is simply 4, and we can bring the root 5 here. So we can basically break down the steps like that too. Or we simply have square root of a divided by square root of b, which we can also write as the whole thing square root of a over b. It is both the same. Now, how do I simplify that? So, if I want to simplify something as simple as square root of 27 over square root of 3, that is square root of the whole thing of 27 over 3, which is square root of 9, which is 3. And moving on, therefore, we can then have the method of rationalizing surds. So what is rationalizing surds? So rationalizing is basically when you have a square root in the denominator, we try to get rid of it. And the method to get rid of it is basically to multiply top and bottom by the same square root value. So here I am multiplying by square root b over square root b. When I do that, it will become a square root b at the top, and the bottom becomes square root of b times square root of b, which is the same as saying square root of b squared. Therefore, that simplifies down to just b. If we look at this with a numerical example, you can see that 6 is over root 3, and we then multiply root 3 over root 3, which becomes 6 root 3 over 3. And this we can then simplify as 2 root 3. Finally, adding and subtracting surds is a bit like adding and subtracting terms in algebraic expressions. So when you have two surds which are the same, you can add them together. So if I have 1 root 5 and 3 root 5, I can add those together to make 4 root 5. Similarly, 3 root 7 take away root 7 can be added or subtracted to give 2 root 7. But if I have root 2, root 6, I can't add those together because the roots are different. But I can simplify 5 root 2 with negative 3 root 2 here, which then gives me 2 root 2, and the 3 root 6 automatically just stays off without simplifying towards the end. Alright, and we are going to finish off with some questions. So the first one is to rationalize the denominator of square root of a over square root of b. So remember, we always multiply by what is in the denominator. So I'm going to multiply here by square root of b over square root of b. So this is going to simplify to square root of ab in the numerator. In the denominator, I am going to have square root of b squared, which is basically b to the power of half times 2, which is b to the power of 1. So this is going to simplify to square root of ab over b. And that is option number 1. Alright, so next one is to put the expression in order from smallest to largest when x equals 2. So the first one is basically saying 1 over x to the power of 2, which is the same as saying 1 over 2 squared, which is 1 over 4. Anything to the power of 0 is always 1. So x to the power of 0 is 1. Then x itself is basically like saying x to the power of 1. So this is the same as saying 2. And we have x cubed, which is basically 2 cubed, and that is 8. So looking at it, the expression is already in order from the smallest to the largest. So therefore, the option number 2 is our correct answer. And finally, the last question, calculate square root of 81. So if you remember, 81 is a square number, which is 9 times 9. So therefore, 9 is the answer for this one. And that brings us to the end of this lesson. See you next time.